Hi everyone, video 59 has been quite a long time coming. I'm afraid I haven't been able to do as many of these as I would like to. Various reasons I won't bore you with, but I thought I'd quickly cover this subject because a friend of mine asked me recently about how to access images of disks that are part of a logical volume management system from Linux, or LVM volume. You can Google what an LVM is, or if you're watching this video you probably know what one is and that's why you're watching this, but very briefly it's the means effectively of creating something similar to a software RAID. So you can take an assembly of disks and you can put them together in one of a variety of ways, including striping, mirroring and so on. This demonstration is just going to show the more simple scenario of where you've got two disks that are both accessible as a logical volume, and basically once disk 1 is full it will overspill into disk 2. The reason why I'm pointing it out as a video demonstration is the fact that sometimes you could add the image of disk 1 and think that everything's okay because it will show you the file system and most of the files should be accessible, whereas the second disk may appear empty and you might just assume that there's a problem or the system was corrupted or something like that. So this is to show you how to put them together properly. So I've created a new case. I'm just going to add the two images that I've got. So I've had two physical disks essentially, although being done in a virtual machine, but two physical disks which I've then added into a logical volume system. And I've just relatively dumbly added the two systems. So this is the image of disk 0 and this is the image of disk 2. So as you can see on disk 0 there's a file system, there's a load of files here that I've copied on. It's an NTFS partition, there's a few folders with some stuff in. If I click on here is a few little test files that I made, and as you can see they all appear pretty much perfectly legible. There's a LibreOffice version of it and so on. There's also in here a load of data, just random files that I've made, and as you can see those two alone are 2 gig on their own, they're 200 meg, and there's a load of other stuff on here as well. So if I just look at this particular drive here, just bear with me for a minute, I'm missing a view that I need. Okay, just sorry about that. Right, just move that over there. So you'll see here the physical drive here, it says total capacity 2 gigabytes, and the same here, it says total capacity 2 gigabytes. So in total that's 4 gigabytes obviously. Now if I just recursively explore this entire file system and do selected, you'll see that it comes to 3.4 gigabytes of data. Well, given that this drive is only 2 gig in size, that already is moderately alarming. So although most of this data is accessible in general terms, so I'm just going to click on a few more things here. We've got a bit of bits and pieces, so on and so forth. It looks okay, but the figures don't quite add up, and this drive shown as an LVM2 container, as is this one, so they're both recognised as LVM2 containers, so that's a really good hint that you might need to do some extra work with this anyway. The sums just aren't quite adding up. So the simple way for this kind of LVM system, note as far as I'm aware Xways can't currently do striped LVM system, so that's where for every file half of it will get put on one disk and the other half will get put on another. I could be wrong on that because the last time I tried this was using 19.6, so unless something's been snuck in that I've not noticed, but As far as I'm aware, that's the case. So in order to recreate this LVM system as the user effectively would have had access to it, I would like to assemble it properly. So to do that, you do it just like you're building a normal RAID. So you go to Specialist, Reconstruct RAID System. It's remembered that from an earlier run, ordinarily that would be empty. So you would choose what you think is your first disk and what you think is your second disk, and the image of. And again, it's gone to JBOD because I used this earlier to do a test run. By default, it will be on level 0, so you'd need to change that to JBOD. And once that's done, all you have to do is click OK. And as long as you got that order right, what you should end up with is a new tab up here, which is basically the reconstructed version of the JBOD system. So if I now add this to my active case, like so, I get seemingly the same partition with all the correct data in there. But this time, selecting all the files, I get 3.4 gig, and the partition itself, it says use space 2.6, free space 834, total capacity 3.4 gig. So then from there, what you can then do, depending on what you need to do with this particular data set, but my general advice for any RAID related system would be to create a new image of the reconstructed RAID system as one complete EO1 image. And you can do that, but you can either do it at a partition basis or more sensibly at the physical level up here. So Alt and Control C, and you can choose where you want your image to go and all the usual settings that you would typically apply. Notice here as well that the scope of the sectors is that, and on this new reconstructed RAID, if I'm in disk mode, I should be able to go to the end of that disk, which I can. So that's the final few bytes of this reconstructed LVM system. Whereas on this one, if I try and do the same thing, notice that that's what it thinks is the current maximum. If I try and go to that same offset, it will tell me I can't do it because it doesn't exist. So that's basically how you reconstruct basic LVM volumes within Xbase Forensics. So an important point as part of your data acquisition, evidence preservation steps. Okay, thank you very much.